Greetings, the Astro 30 here, yet again with another, well, this is going to be an attempt at repairing something. I've got sitting on the desk here another amplifier to look at. It's a Technics SA-R177 stereo receiver. So it has a built-in AM/FM receiver as well as your standard line inputs, etc. And it's only stereo, it's not surround sound or any of that rubbish. And you can hook up 2 sets of speakers to it. So it's got speakers A and B on it. And a lot of buttons to press. Ooh. Anyway, the complaint on this one is that there's no sound output, which we're off to a great start with that. And I've had a quick look in through the vent holes at the top, and it's a module amplifier. That is, it uses one of those old Sanyo style SDK modules as the output amplifier. And if that's bad, it's all over for this, because good luck trying to find a working genuine one. And if you do, it'll be super expensive. So this may not be able to be repaired if it happens to be that. However, let's not get ahead of ourselves. Let's plug it into the dim bulb and turn it on and see exactly what it does and verify the complaint. And then we'll go from there. Now, the guy that owns this said he doesn't want to spend like $100 on this to repair it. If it's something simple, fine, but if it's unrepairable, well, it's unrepairable. So, dim bulb is off, so I'll turn him on. Nothing happened. Oh, well, it powers up at least. And it's currently set to the radio. However, I do not hear a click of a relay, if it even has one. So how do you change the inputs on this? There we go, change that to CD so it's on that input. Display's nice and bright, but yeah, alright. So what I might do is I might actually pull the top off and just have a look inside the unit, see if there is a relay there that should be engaging, and then go from there. Well, I don't see a relay, so I don't know if that's good news or bad news, but there is definitely no relay in here at all. Well, it's not actually an SDK chip. It's similar. It's an SV13102 or SVI3102 stereo amplifier chip. Interesting. So what I'll do is I'll hook up one speaker to the amplifier's A output and see if it makes any strange noises. Okay. Nothing unusual is coming out the speaker. And there's nothing coming out the speaker at all, not even a hiss. How? I don't know how this unit protects from DC, if it does at all. So it could literally destroy your loudspeakers. Alright, what I need to do is pump in a signal. I have my oscillator from the oscilloscope going in, and I hear nothing coming out. So what I might do, I might plug into the headphone jack, because that might have its own separate amplifier, possibly, and see if I can hear the tone or anything. But currently I can't hear anything coming out the speakers. There's a hum. I can hear a hum. Alright, and that's on the right, the left hand channel. Yeah, no, the right channel. So multimeter time. Alright, I've got the multimeter hooked up across the right hand channel where I can hear the hum in the headphones. Whoa. Yeah, that didn't look too great. "24 volts on that channel." There's DC on the output, and there's no DC protection either on this amplifier. Lucky I didn't hook a speaker up to that channel. It'd be dead. So let me just check the left. Well, it looks like there is nothing present on that channel. No, there's not. It's only like 21 millivolts, so the speaker was completely safe on that channel. But yeah, we've got DC on the output on one channel, in this case the right hand channel, so I'm pretty confident at this point that yeah, it's got to do with this amplifier module, which is not getting that warm, but it's not passing the signal through either. So yeah, this could be a problem. Because I don't think I'm going to be able to get that IC. So I don't know what I'm going to do right now at this point. I mean, I could measure voltages around the circuit to see, you know, what is present where and what it is, and see if I can find a data sheet on that particular output module, and well, see if I can, you know, work out how it's supposed to be wired in the circuit, so I can do some further testing and see if the signal is actually making it to the amplifier. But because there's DC on the output, well, it's a good possibility that yeah, there's an internal problem with this IC. So there are two transistors mounted to the heatsink here as well, but I'm not sure what they do. Actually, no, there's nothing mounted there. There's one mounted there. Oh yeah, there it is. I don't know what they do, but anyway, I don't know if I can find a schematic on that. This will be handy if I can. So yeah, well, there we go. Well, I found the service manual, and I spent half an hour looking at the schematic just to try and figure out how to follow it, because it was a little bit confusing to start with, because it's a single PCB split over multiple pages. But I figured it out. I know a little bit more about this particular IC. This is a Panasonic device. It's actually made by Panasonic, which stands to reason because it is a Technics unit, and Technics is Panasonic. I also know that pin 1 and pin 4 of this IC are the outputs, and pins 2 and 3 are the supply rails. So because the right channel has DC on its output, I'm just going to check to see whether or not you know, the output stage is shorted to one of the supply rails, indicating we've got a shorted output stage. So I'm going to do a continuity test with that. Now, pin 1 is the left hand output, or the left channel, and that's the supply rail. That's pin 2. That's also a supply rail. There's nothing there, and between both outputs there's nothing. So I'll switch to pin 4. Nothing. Nothing. Okay, so the two supply rails themselves completely open. So what did that prove? Well, absolutely nothing. But the output stage doesn't appear to be shorted. However, there could still be internal damage somewhere in here that we can't see, which is causing that problem to be existent. So the next thing to do is, with any fault finding of a problem with an electronic device, is thou shall measure voltages. I also know that this chip uses a negative 15 volt reference voltage on pins 5 and 8, which come off of the minus 15 volt regulator. Regulators are actually mounted to, well, the transistors for the regulators are mounted to the heatsink too, so that's also handy. So if this chip is not getting its negative 15 volt rail, well, that could be an indication why it's not functioning. And because that negative 15 volt rail also powers the op amps that could be the reason why we've got no signal output on the left channel, which appears to be working. Okay, so I've got my positive multimeter probe grounded to the chassis, and I'm sitting down here because I need to get in here without shorting stuff. So the camera's kind of far off to my left. So I'll just turn the dim bulb on and the unit on. Okay, so I want pin 8. 4, 5, 6, 7, 8. There appears to be bugger all there. Okay, so pin 5 is there. -2 volt. Well, there's a problem. Because both pin 5 and pin 8, it's 5, 6, 7, 8. Oh, there it is there. There's the 14.1, which is close enough. And pin 5 doesn't appear to have anything on it. Well, that could be a problem. Also, pin 6 is being used differently to the data sheet, which is not very helpful, by the way. That's some form of AC power on detect, and there should be 0 volts on that pin. So pin 3, 4, 5, 6, yeah, we got 0 volts there, but the one next to it, pin 5, doesn't have any negative voltage on it apart from, yeah, nothing. Because my probe's around the other way, so that it should be a positive 14 volt, but there's nothing there. Okay, so that's interesting for a start. Turn that off. So why? Well, here is pin 8, which is getting our 14 minus volts thereabouts. But this pin here, pin 5, is going through, in this case, a 680k resistor with a bypass capacitor across it. So if this 680k is open, then, well, we're not going to have the minus 14 odd volt here. So the next thing to do is I need to locate R628 on the PCB and measure its resistance. And R628 is behind this ceramic capacitor right there nearest the IC, because if I measure across that resistor, well, initially we get close to a resistance, but then the capacitor starts charging and the resistance goes up. And just to prove that the capacitor going across the resistor in that circuit isn't going to affect the reading of resistance, you should still have a resistance reading there, because these have relatively low ESR anyway. I've got this little demonstration here. I've got a 47k resistor across a 1 microfarad 100 volt cap, similar to the 680 kilo ohm and 10 microfarad 100 volt cap in that unit respectively. And if we measure the resistance across this resistor, we can see that when the meter ranges, we get 47k. So the capacitor is not really having an effect on the resistance reading. So that indicates to me that that 680k resistor is open. If I measure the voltage now at the end of this resistor to see like if there's any difference, which it probably won't be. Okay, so turn the unit back on. I will measure the voltage at the other side of that resistor. I'm getting the same thing. So if I measure it on the other side of the resistor, which comes off of the regulated side, there's our 14 volt. So the next course of action is I'll just make sure that both supply voltages, the high side, the plus minus 35 volts, are at pin 2 and pin 3 respectively, which they should be, because, well, if they weren't, then it wouldn't operate correctly. There'd be DC on the output on both. Pin 2, we've got minus 31 volt there, so that's positive 31 volt, and pin 3 we have a minus 31 volt rail. So both rails are there, so that's good. We know that the power supply is functioning, all voltages are present and correct. And just for shits and giggles, IC501 is the buffer amplifier before the power amplifier. I'm just going to measure across pins 4 and 8 and make sure we've got 30 volts there. Well, in this case I'll just see if we've got both supply rails to pin 8. We should have The 15 volt, which is plus because the lead's around the wrong way, that's fine. And pin 4 should be the negative supply rail, if I can get on there. And we know that that was existent in the first place, so yeah, the op amp is also getting the power. Anyway, the only problem with doing any work on this is you'd have to pull the whole entire amplifier apart in order to take the PCB bit out to, you know, do any soldering work on it, which is frustrating as hell. I can get this IC online on Evil Bay for around about $20 Australian, plus about another $10 Australian for shipping from China. No guarantee it's going to work, but yeah, it's worth a try. The last thing I'm going to do before I condemn this IC is I'm just going to make sure that the input signal is coming all the way through the audio chain to the inputs of the power amp. So if we have a signal at the inputs of the power amp but nothing at the output, well, we know there's something wrong with the IC. Plus we also know that there's no negative 14 volt voltage getting to pin 5. Okay, so our inputs to the power amp are pins 13, which I believe is for the left, and pin 11. So there should be a signal on both of those pins. Okay, so I'm going to use my signal tracer for this. Now the amplifier is off, but I should have a signal coming in the CD input, which I do on both channels. I'll turn him up a bit. Wrong one. Okay, turn the amplifier on, and we need pin 11. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's that one there. Nothing. Oh yeah, there's the signal. Volume pot's a bit scratchy. Pin 13. There's our signal. However, the left is weaker than the right. Or the other way around, the right is weaker than the left. Anyhow, we know that the signal is making it all the way up to the power amplifier, it's just not coming back out. Now, I don't have a 680k resistor, so I've bodged in a 470 and 220k in series across that 680k resistor that's in there. And now I'm going to measure the voltage at pin 5 and see if we have the negative 14 there. Now, if there's a catastrophic fault with the amplifier now, everything's on the dim bulb, so nothing's going to smoke or blow up. That's the theory anyway, so I'll give it some power. Nothing unusual. Right, let's have a look at the voltage. Pin 5. No, there's still minus 2 volt there, or nothing. So there may not be anything wrong with that resistor. It may actually be the capacitor that's across it. And without pulling the PCB out, I've got no way of testing that. I hate red herrings. Well, I've removed that resistor I put in there and put it back to the way it was. And I did actually test this 10 microfarad 100 volt, not sure why it's 100, but it is. That is measuring at just over 10 microfarads, so the capacitor's fine. So the only other thing I can think of is pin 5 of the IC must be holding that voltage down somehow. But I can't find any short to ground or negative or anything on pin 5. So the upshot of that was a complete waste of time. If I measure across that 680k resistor and just let the capacitor charge up and the meter range, it'll come up to about 680k, go a little bit over and then stabilize. So as we can see, it's climbing, and we're sitting at, it's really hard to get a good connection, well, 698k, 99, roughly thereabouts, going up and down, then coming back down. I think that resistor is perfectly fine, and so is the capacitor. So I believe that the original issue is confirmed, that this power amplifier IC is damaged. means I'm going to have to replace it. And when I actually take the PCB out to replace it, I'll pop that resistor out of circuit, clean him up because I've got solder on his side now, double check the resistance out of circuit, make sure it is functioning. Capacitor, as far as I know, is functioning. So yeah, and yeah, it's really awkward having to take the PCB in and out to do this sort of thing because there's no removable bottom panel on this amplifier to make it easier. Of course there's not. So I have to disconnect everything, pull it out, do the work, put it back in and assemble the amplifier to a certain point where I can test it and see if I've made a difference. So there's quite a little bit of effort involved of taking it apart and putting it back together, which is thoroughly annoying because the front panel will have to come off, the rear panel will have to come off, things would have to be disconnected, like the interconnects between the power supply board and the main board and all of that, which is going to be fun. But I think what I might do is I might order the IC. It's going to take about 3 weeks to come from China, unfortunately, and then I'll make this into a second part. So I'll leave the video here for this point and upload what I've got with my findings. Now, I do this as a hobby. I haven't been in the electronics servicing industry for over 25 years, but I like to make videos like this so I can show you my thought process behind why I do what I'm doing. And yeah, it was pretty obvious at the start that yeah, there's a problem with the IC, just replace it. But it's always good to make sure that, you know, you've got all the power supply voltages required in the circuit and around the circuit, or else obviously the circuit's not going to function. And also there's like no obvious open components or obvious bulging capacitors and things like that. So I'll get that done and ordered, and probably won't order it till next week now, but that's beside the point. So I'm going to leave this video here, and if you enjoyed it, please remember to comment, rate and subscribe below if you haven't done so already. And as always, this is the Astro Thief saying, see ya, have a great day, I'll see you in the next one.